Hello, we're looking at section 2.4. Make that 2.3 when we're talking about inverses. And they want us to find x so that we have the inverse is equal to itself. All right. We know that the inverse of a 2x2 matrix is going to be 1 over the determinant, which is the product of the diagonals. That's -4 minus the product of the wings, which is going to be 2. I'm sorry, -1 times x, so it's -x. And then inside of the matrix, we switch the diagonals and we throw a negative on the wings. So this becomes a +1 and a -x. All right, we can kind of work this out as +x minus 4. And so we'll have a -2 divided by x minus 4, -x divided by x minus 4, +1 divided by x minus 4, and 2 divided by x minus 4. And just by inspection, we can kind of see that we want x minus 4 to be equal to -1 to match this up. And then we'll find out what x is. So if we, for example, just take a look at the first component, if we want a to be equal to a inverse, then we want those two to be equal to each other. So that means we want 2 to equal -2 divided by x minus 4. And so if we solve for this, and we're going to get x minus 4 is equal to -1. And then we add 4 to both sides, we're going to get x is equal to +3. So when x is equal to +3, this fraction is going to be -1. And so let's say x is equal to 3. Then a is equal to 2, 3, -1, -2. And then a inverse is equal to, so if we put 3 in there, we're going to get -1. That's going to be a +2. This will be a -3 divided by -1. That's a +3. And 3 in here, this will be a -1. And then 3 into here, this will be a -1 times 2. It's -2. So they are, in fact, equal to each other. And that checks out. Okay. I hope that helps.